Picture Antarctica today, a frozen wasteland covered in ice sheets up to 3 miles thick, with temperatures dropping to -128 degrees Fahrenheit. It's the coldest, windiest, and driest continent on Earth. A place where only the toughest researchers and the most specialized wildlife can survive. But Antarctica wasn't always this way. In fact, if you could travel back in time, you'd find a completely different world, one that would absolutely blow your mind. About 90 million years ago, during the middle of the Cretaceous period, Antarctica was practically unrecognizable. Instead of the barren ice desert we know today, it was covered in lush, dense forests. The kind of forests that would make you think you'd landed in the wrong place entirely. Scientists discovered this shocking reality when they analyzed a soil core drilled from the seabed near the Pine Island and Thwaites glaciers in West Antarctica. What they found was remarkable. The sediment contained ancient forest soil, pollen, spores, and even root systems so well preserved you could still see individual cells. This wasn't just some sparse vegetation either. We're talking about a thriving temperate rainforest similar to those found in New Zealand today. The average temperature would have been around 53 degrees Fahrenheit, with summer temperatures reaching into the 70s. That's warm enough to go swimming in Antarctica, which is absolutely wild to think about. The forest was dominated by conifers, but also included ferns, flowering plants, and trees that would have created a dense canopy. It would have been humid, warm, and teeming with life. The kind of place where you could walk around in a t-shirt and shorts, surrounded by the sounds of insects and birds. But wait, how is this even possible? Antarctica sits directly over the South Pole. Even with warmer global temperatures, shouldn't it still be dark for months at a time during the polar winter? That's one of the most fascinating parts of this discovery. Antarctica was still at a high latitude back then, meaning it experienced months of darkness each year, just like today. But somehow, these forests not only survived but thrived despite going without sunlight for up to 4 months annually. This challenges everything we thought we knew about ancient forests. These plants somehow adapted to the extreme light conditions, growing rapidly during the summer months when sunlight was constant, and then going dormant during the dark winter. It's a survival strategy we don't see in modern forests. The carbon dioxide levels during this period were incredibly high, between 1,000 and 1,600 parts per million, which is about 4 times higher than today's levels. This created a powerful greenhouse effect that kept the continent warm even during the dark winter months. The discovery of this ancient forest isn't just a cool science fact, it has serious implications for our understanding of climate change. It shows that with enough greenhouse gases in the atmosphere, even Antarctica can become a lush, green paradise. But it also serves as a warning about how dramatically our planet can transform when carbon dioxide levels rise significantly. What's particularly concerning is that the levels of CO2 that transformed Antarctica into a forest paradise are levels we could potentially reach again by the year 2100 if current emission trends continue. While we won't see forests growing in Antarctica anytime soon, the ice sheets would take thousands of years to melt completely. It does show the potential for dramatic climate shifts. The wildlife that inhabited this prehistoric Antarctic forest would have been just as surprising as the forest itself. While we don't have direct fossil evidence from this particular site, we know that dinosaurs were roaming all continents during this time, including Antarctica. Imagine dinosaurs walking through dense Antarctic forests, not trudging through snow, but navigating between tree ferns and conifers. There would have been small mammals scurrying around the forest floor, along with insects, amphibians, and early birds flying through the canopy. In the waters surrounding Antarctica, you would have found marine reptiles like plesiosaurs and mosasaurs, along with ancient sharks and fish. The entire ecosystem would have been completely different from what we see today. But this wasn't the only time Antarctica was green. If we go back even further, to about 250 million years ago during the Permian period, Antarctica was actually part of the supercontinent Gondwana, connected to what is now South America, Africa, India, Australia, and New Zealand. During this time, Antarctica was positioned much closer to the equator and was home to a diverse range of plant and animal life. Fossils of Glossopteris, an extinct seed fern, have been found across Antarctica, providing some of the earliest evidence for the theory of continental drift. As Gondwana began to break apart about 180 million years ago, Antarctica slowly moved toward its current position over the South Pole. But it remained connected to Australia and South America for tens of millions of years afterward, allowing plants and animals to move between these landmasses. One of the most fascinating fossil discoveries in Antarctica is that of Antarctopelta, the first dinosaur found on the continent. This armored dinosaur, similar to an ankylosaur, lived during the late Cretaceous period when Antarctica was still connected to South America and Australia. We've also found fossils of massive marine reptiles like plesiosaurs, along with evidence of forests containing southern beech trees, conifers, and ferns. These discoveries paint a picture of a much warmer, more vibrant Antarctica than the one we know today. So what happened? How did this lush forest paradise transform into the frozen continent we know today? The big change began about 34 million years ago, at the boundary between the Eocene and Oligocene epochs. This is when Antarctica began to develop its first ice sheets. The trigger was a combination of factors, including the final separation of Antarctica from South America and Australia, which allowed the Antarctic circumpolar current to form. This ocean current essentially isolated Antarctica from the warmer waters of the global ocean, creating a thermal barrier that prevented warm water from reaching the continent. At the same time, global carbon dioxide levels were declining, reducing the greenhouse effect that had kept the continent warm. As the ice began to form, it created a positive feedback loop. The white surface of the ice reflected more sunlight back into space, cooling the continent further and allowing more ice to form. Over millions of years, this process transformed Antarctica into the ice-covered continent we know today. The last forests in Antarctica probably disappeared around 15 million years ago, during the Middle Miocene, when a significant cooling event caused the ice sheets to expand dramatically. Since then, Antarctica has remained largely frozen, with only specialized mosses, lichens, and 2 species of flowering plants able to survive in the most favorable locations. But the discovery of this ancient forest soil reminds us that Earth's climate is not fixed. It has changed dramatically in the past and will continue to change in the future. The frozen continent we know today is just one phase in Antarctica's long and varied history. This also gives us a window into potential future scenarios. While it would take thousands of years for Antarctica's ice sheets to melt completely, even under the most extreme warming scenarios, the continent's past shows us what's possible given enough time and the right conditions. If all of Antarctica's ice were to melt, global sea levels would rise by about 200 feet, dramatically reshaping coastlines around the world. Major cities like New York, London, Shanghai, and Sydney would be underwater. The fresh water entering the oceans would also disrupt global ocean currents, potentially causing significant changes to climate patterns worldwide. But even small changes to Antarctica's ice sheets can have significant impacts. The Pine Island and Thwaites glaciers, near where the ancient forest soil was discovered, are already losing ice at an accelerating rate, contributing to rising sea levels. The story of Antarctica's forests serves as both a fascinating glimpse into Earth's past and a sobering reminder of how our planet can change. It shows us that what we consider permanent features of our world, like the ice-covered Antarctic continent, are actually temporary on geological timescales. So next time you see images of Antarctica's vast ice sheets and barren landscapes, try to imagine it as it once was, a warm, humid forest teeming with life, where dinosaurs walked among tall conifers and ferns, even during the long polar night. It's a reminder of our planet's incredible history and its capacity for change. And perhaps most importantly, it's a reminder that the actions we take today to address climate change will shape what Antarctica and the rest of our planet will look like for generations to come.